Alright, in the first video, we talked about the history of atomic structure, who discovered what, and the sequence of discoveries, what particles were discovered first, and so on. In this video, we're going to answer the question, what the heck are atoms anyways? What are they composed of? Kind of bring it all together into a single, coherent idea. First of all, atoms are the basic building blocks of matter. It's what the elements are made of. Now, these atoms are not just solid chunks of matter. They're composed of three smaller subatomic particles. Those three particles are electrons, protons, and neutrons. This is the order in which they were discovered. Electrons were discovered first by J.J. Thomson, then protons were discovered second by Ernest Rutherford, and then neutrons third by James Chadwick. The electron is a small particle with a negative electrical charge. The protons have a positive electrical charge. These two end up canceling each other out, making matter neutral. The third particle has no charge at all. A few basic things that we need to know. We need to know how these things are put together. We need to know their structure. In an atom, you have a densely packed cluster of protons and neutrons called the nucleus. The nucleus of an atom is a teeny tiny little part. In this drawing, it's nowhere near to scale. If the atom were this big, the nucleus would be a tiny little dot in the middle. Inside that little dot, you find all of the protons and the neutrons, all of the positive particles, all the neutral particles. Outside the nucleus, we have a region of space called the electron cloud. Surprise, surprise, you find electrons there. The electrons are moving randomly inside of energy levels outside of that nucleus. These circles don't represent orbital paths or circular paths, but they represent the energy levels that the electrons are found in. This would be the first energy level, the lowest energy level. This would represent the second energy level in the atom. There are 7 energy levels that we know of. The nucleus, because it contains all the protons, has a positive charge. The electron cloud, because it contains all the electrons, has a negative charge. The electrons are attracted to this nucleus because they're oppositely charged. Protons are positive, electrons are negative. There's a force of attraction between the two, much like taking the opposite ends of two magnets. Those magnets would be attracted to each other. The electrons and the protons are also attracted to each other. Some basic things you need to know about each of the particles. First, masses. Electrons have very little mass. About as small a matter as you can get. Smallest piece of matter that you can get. About. Not the smallest, but very close. Protons have much larger mass than the electrons do. Neutrons also have much larger mass than the electrons do. To give you a rough estimate, protons and neutrons are about 1,800 times larger than the electrons. To put it in perspective, if protons and neutrons were the size of a small car, if you blew up an electron the equal number of times, it might be the size of something like an apple. Very different in terms of their sizes. Protons and neutrons are much, much larger than electrons are. Because of that, when we start working on calculating the mass of atoms, these are the only things we look at. Again, electrons have a negative charge. Protons have a positive charge. Neutrons have no charge at all. Neutrons are neutral. A lot of students make a mistake when they're trying to learn this. They think protons positive, they see the 2 P's, and they immediately start to think that neutrons are negative, but that is not the case. The root of the word neutron is neutral, which is what they are, no charge. They are neutral. Electrons are negative, and what I always tell my students is to think of the word electron, to look at the word electron and see the word electricity in it. And when you get shocked by electricity, it's a real negative thing. That can help you remember that the electrons are negatively charged. Location, we've got to know location. Again, as I mentioned in the slide before, the electrons are found in the electron cloud. That's that region of space outside of the nucleus. The protons and the neutrons are found inside the nucleus. Last thing on my little table here is what they do. Each subatomic particle has a role to play in our atom. The electron, the big role, what we'll be learning this year, electrons determine reactivity. Whether a substance is reactive or stable depends entirely on its electrons and how many electrons it has. The proton's job, as we're going to learn, is about identity. Protons determine what the element is. If the number of protons ever changes, that atom becomes an entirely new element. And the job of the neutron, nuclear stability. We have all the protons jammed together in the nucleus. They don't want to be together. They all have positive charges, and because they all have the same charge, they repel each other. It's like taking the north end of two magnets and trying to stick it together. They repel. When all these protons are jammed together in the nucleus, they repel each other just like the magnets do. Now think about it as you and 15 of the people you absolutely cannot stand in this world, the people that you hate the most, and you're all stuck together in a broom closet. You don't want to be there. You want to get out as bad as possible. There's a lot of repulsion between you and those people. The neutron, that's like your best friend. It gets between you and those people you don't like, kind of makes the peace, keeps you from repelling each other, keeps you all stuck together. That's what the neutrons do. They keep these protons from repelling each other. They keep these protons jammed together in the nucleus. It's a list of things that I would expect everyone in every one of my classes to know about the atom. Atoms are mostly empty space. Kind of odd to think about it, but I am mostly empty space. This board is mostly empty space. This camera that's recording all this is mostly empty space. I read an interesting quote in a book a while ago. It said, if you could take all the empty space out of all the humans in the world, then we'd all fit into the space of a sugar cube, about 1 centimeter by 1 centimeter by 1 centimeter. If you could get rid of all the empty space in the entire human race, that's how small we would be. You take out all that empty space, compact all that matter together, we'd all fit in a sugar cube. Pretty amazing to think about that. Most of an atom's mass is in the nucleus. Mention this with the protons and the neutrons. Protons and neutrons are large particles. Protons and neutrons have a lot of mass. Because they're found in the nucleus, we can say the nucleus has most of an atom's mass. Most of an atom's volume is in the electron cloud, as I mentioned when I was looking at the model. The nucleus is this teeny tiny little dot in the middle. The rest of the atom is electron cloud. When we talk about how big an atom is, it's all about the electron cloud. Again, volume measures the size of the object, how much space it occupies. Most of an atom's space or volume is in the electron cloud. The motion of electrons are random. Got to mention this because a lot of students are taught the planetary model in lower grades. The planetary model tells us that the electrons go around the nucleus in nice circular paths, like planets orbiting the sun. We know that is not true. Their motion is not predictable. Their location is not predictable. Electrons move totally randomly. They could be in one place one moment and somewhere else the next. We cannot predict where they go, and because we can't predict where they go, we can't say they're moving in nice circular paths. The best analogy I've seen compares the electrons to moths flying around a light bulb. The nucleus is the light bulb, and the electrons fly around that nucleus much like moths would fly around a light bulb. So open the door at night, look at the porch light, look at those moths flying around the light bulb. That's what the electrons are doing around the nucleus. They're just flying everywhere. The electrons are attracted to the nucleus. They are not attached to the nucleus. They are free to go wherever they want to. Their motion is random. An electron can leave one atom and go to another. They're not chained in place. There are no walls. There are no barriers. Just like the moth and the light bulb. There's nothing that keeps the moth at that one particular light bulb. It's free to leave and go to another one if it wants to. It may come back later on. Electrons will behave in much the same way. They are not attached to the nucleus. They are attracted to the nucleus. They want to be near it because of the opposite electrical charges. The electron is negative, the proton is positive. They are attracted to each other because of that opposite charge. And finally, protons are repelled by each other. Protons have a positive charge. Whenever two positives come together, they want to get the heck away from each other. They want to go in opposite directions. They are repelled by one another. It's like taking the north end of two magnets and bringing it together. They'll push apart. Protons do the same thing. And all those protons are jammed together in the nucleus. They're jammed in this tiny little space. There's a lot of stress there. There's a lot of repulsion there. The only thing that keeps the nucleus from flying apart are the neutrons. The neutrons produce what are called strong nuclear forces to hold that nucleus together. And that's your basic picture of what atoms look like. It's more complicated than that. You'll learn that in your chemistry classes when you start talking about things like orbitals and probabilities and electron configurations. But for physical science, that'll do. As is always the case, if you have any questions or concerns, please post them to the wall or ask me before or after class.